All right, problem 5 wants to know when production is increasing most rapidly. This is the number of a certain item, the amount produced, where T is in hours since the beginning of the day at 8 a.m. What is the time that production is increasing the most rapidly? That's actually going to happen at the inflection point. So curve will have the highest slope where the function changes from concave up to concave down. So in order to get that, we are going to first differentiate A, which will give us, let's see, 48 minus 12 times t minus 3 squared. Then we need to differentiate again to get a double prime, which will be negative 24 times t minus 3. So in order to find out when the second derivative changes signs, I think that one actually we can just look at it and see that that happens at t equals 3. So this is my second derivative number line here. And let's see if this is the beginning of the workday at time equals 0 here. So if we plug in, say, 1 o'clock, we're going to get out a negative times a negative, which is positive. And if I plug in, say, 4 o'clock, or actually 4 hours, which would be noon, I would get out a negative here. So production is going to be increasing the most rapidly at this positive inflection point when the graph changes from concave up to concave down. That's where t equals 3. The answer is C. So go ahead and do number 6 here. They're giving us a function. They're telling us that the function is everywhere differentiable, and here are some values for the derivative. And they're saying if f prime is always increasing, what must be true? First of all, f prime increasing means that f is concave up. That's f concave up. And it means that f double prime has to be greater than 0. So we know that this is not concave down, and we're not sure about anything else. Okay, so if f prime is always increasing, let's see. That means, let's think through this. If f double prime is always greater than 0, and we know the first derivative is 0 at the origin, we can use the second derivative test to prove A, that f must have a relative minimum at x equals 0 because the first derivative is 0 and the second derivative is positive.